Hi everyone, this is your math guru. In this video, I'm going to use the following examples to prove the circle theorem that states that the line drawn from the center of the circle, if perpendicular to a chord, bisects the chord. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example, I have a circle. The black dot is the center of the circle. The theorem that states that the line drawn from the center of the circle perpendicular to a chord bisects the chord, that is, divides the chord into two equal parts. So for example, if I have a circle with center O and I have a chord, if I draw a line from the center of the circle and it's perpendicular to the chord, then the line on my left and on my right are equal, that is, the perpendicular line bisects the chord. If you look at the circle shown, I have the center O, so therefore this is the diameter of the circle. The line drawn from the center of the circle is perpendicular to the chord as shown, and it forms 90 degrees. Therefore, this line is equal to this line. That is, x will be equal to 6. And the reason is the perpendicular bisector of chord. Let's look at another example. In the second example, I have another circle with diameter as shown 18.8 units. To find the radius of a circle is equal to half of the diameter. Therefore, the radius r equals half times the diameter as given in the diagram is 18.8. Half of 18.8 is 9.4. So therefore, the radius, which is the line from the center of the circle to any part of the circle as shown, is 9.4. So if the radius is 9.4, I have x plus 4.2 equals the radius, which is 9.4. Using the balance method, x equals 9.4. I'm going to subtract 4.2 from both sides. Therefore, my x equals 5.2. And the check is, if x is 5.2, 5.2 plus 4.2 will give me the radius, which is 9.4. Let's look at other examples. In this next example, I have a circle with center O. If this is the chord, and I can see the line drawn from the center of the circle perpendicular to the chord. Therefore, the circle theorem that states that the line drawn from the center of the circle perpendicular to the chord bisects the chord. This means that the line from here, from the middle of the chord, is equal to the other line. If I tag this A, B, and C, the rule states that if OB is perpendicular to line ABC, therefore AB, the line AB, is equal to the line BC. Therefore, we've been given line BC to be 10.6, line AB will be 10.6. That's equal to 10.6. So I have two triangles, 1 and 2. Looking at triangle 1, I'm going to make a rough sketch here. I have my 90 degrees, I have my B, I have my O, and I have my A. I am looking for x, which is also the radius, that is the line drawn from the center of the circle to any part of the circle. Thus AB is 10.6 and OB has been given as 4.3. Using your Pythagoras theorem states that the hypotenuse squared is equal to your opposite squared plus your adjacent squared, or you have your r squared equals to x squared plus y squared. In this example, my hypotenuse is my x, so I have x squared equals my x and y axis. I have 10.6 all squared plus 4.3 all squared. I'm going to tag my triangle. This is my r, this is my y, and this is my x. Therefore, if I punch that in on my calculator, I'm going to have x squared equals 10.6 squared, that's 112.36, plus I have 4.3 squared, that will give me 18.49. Note that all my calculation is to 2 decimal places. Therefore, my x squared equals 130.85. To find x, I'm going to find the square root of both sides. Whatever you do on your left, you do on your right. Therefore, my x equals 11.44 to 2 decimal places. Let's look at one more example. In my last example, I have another circle with center at O. Remember, the line drawn from the center of the circle to any part of the circle as shown is my radius. So therefore, I'm going to construct another radius here such that that line will be 18.9, which is similar to the radius given. Also, I'm going to look for this distance from O to this point. Let me label that point. I have A, B, C. This is point D. OD is equal to OA, their radii, and that's equal to 18.9 unit. I'm going to look for my OP. If on a straight line, the angle is equal to 180 degrees. So if this is a right angle, this is also a right angle. So I'm going to draw out a rough sketch of that triangle. This is a right angle. I have my O, I have B, I have A. My OA has been given as 18.9 and my AB has been given as 15.7. To find OB, using the Pythagoras theorem, I have the hypotenuse, that's the r squared, equals my x squared plus my y squared. My r squared in this case is my hypotenuse, so I have 18.9 squared equals x squared, that's 15.7 squared, plus y squared. Using the balance method, my y squared is equal to, I'm going to take 15.7 squared to the other side, and because that's a plus, it will be a minus, that's minus 15.7 squared. Therefore, my y squared is equal to 1357.21 minus 246.49. Y squared equals 110.72. And to find y, I'm going to find or square both sides. Therefore, my y equals 10.52. Remember, my y is also equal to my OB. So slotting that back into the diagram, I have OB equals to 10.52. Note that the radius is also, let me tag this point as E. OE is also the radius, and we've been given the radius to be 18.9. Therefore, the OE is also equals to the radius, which is 18.9. 18.9 is also equal to 10.52 plus x. Therefore, making x the subject of formula, x equals 18.9 minus 10.52. Therefore, my x equals 8.38. Thanks for watching. Bye.